Hey everyone, welcome to Pineapple's Principles of Physics. I'm Nick, and today we're going to be talking about thermo and stat mech, okay? So I'm going to be showing you guys the framework that I use to solve pretty much every single thermo and stat mech problem. So the first things that you need, is getting right into it, is you need to know the difference between extensive and intensive variables, okay? So there's really only 6 total variables. So 3 of them are intensive and 3 of them are extensive. So the extensive ones depend on the size of the system. You can think of it that way. So number of particles, volume, and energy. And then the intensive variables don't depend on the size of the system. So like temperature, pressure, and then chemical potential as well. Okay. And the next thing that you're going to need is you're going to need the first law of thermodynamics. So this basically just tells you that the change in the energy is related to the change in the entropy, volume, and the number of particles. Okay. And then from here, you can also show that this is true. This will also be helpful later as well. So the last thing also is you need to know the definition of the free energy, and then you also need to know the partition function definition as well. So essentially with the partition function, you're just going to be adding up all the microstates of the system. So this will also depend on the ensemble that you choose. So the way that you start every problem is you always choose your ensemble. So you pick what variables you want to care about, what variables are going to change out of equilibrium. Okay, so these will be 3 variables that you decide to fix. Okay, and then out of equilibrium, these will be the variables that will change. Okay, so what you do is you pick either n or mu. So the extensive and the intensive variables are like analogous to each other. So n is analogous to the chemical potential, the volume is analogous to the pressure, etc. So in the first slot, you pick n or mu. In the second slot, you pick v or p. In the last slot, you pick e or t. Okay? So that's what you do. You specify 3 variables. And then afterwards, what you do is you write the entropy as a function of the extensive variables. So the entropy is extensive. It has to be a function of the extensive variables that are not listed here. Okay? So, for example, if you were to pick n, p, and t, then the entropy has to be a function of extensive variables that are not specified here. So v is 1, right? N is extensive, but it's specified. V is extensive, and it's not specified. And then e is extensive and not specified. Okay, so we'll call these Q sub I, all right? And then from here, all you need to do is calculate this one sum here. So I'll just call it A, and you just do the partials with respect to each variable, that's the entropy as a function of, times that variable, okay? And then from here, once you have this, you pretty much have everything you need. So from here, you can get that the free energy will just be T times A minus T times S. Okay? And then you can also get that the partition function will be, so in continuous systems, this will turn into an integral. But I'm just putting a sum here, just generally speaking, it's a sum over something. So an integral is just the limit of a sum as the pieces get small. So I'm just going to keep it as a sum for now. And then this will just be e minus 1 over kb times a. Okay. Once you have these two things, you can also relate the free energy to the partition function via this. And then once you have these things, you can pretty much do any thermodynamics or any statistical mechanics that you need. So if you need to find the average energy of a system, you can use this. If you need to find the chemical potential of the system, you can use this. So basically any problem in thermodynamics or statistical mechanics you can solve once you have these two things. Okay? So this video is just showing you the framework. I will have another video linked in the description that will show you a specific problem that actually uses the framework and then solves the problem with the framework. Okay? Thanks for watching.